Alright, so today we're going to be going over multivariable limits. So the difference between multivariable limits and regular limits for only single variable is, let's say we have a point here on 1, 1. So the point's just going to be 1, 1. With regular limits for a single variable, you can only come off of the left side or the right side. So the only ways you could get to this point are this or this, which is different than multivariable. Multivariable limits is I could come over from any way, no matter where I'm coming from. There's infinite many ways to get to the point. So we need to answer their questions a little bit differently. So if we have the function 1, 1, or if we have the function x minus 1 divided by y minus 1, what we're going to do is we need to find a point that gets to 1, 1. So we could have it as x is equal to 1 or y is equal to 1, but our first one that we're going to do is we're going to have it go along the line of y is equal to x. And we will do this in yellow, and this is going to be our yellow line. So we're going to have y is equal to x. So we're going to now find the limit as x approaches 1. Because if our y is equal to x, for our function we can just replace our y with x. So this will now instead be the f of x and y, it's just going to be f of x and x, which gives us the limit as x approaches 1 of x minus 1 divided by x minus 1. And here you could either do L'Hopital's rule or just cancel them out. So to make it a little bit quicker and easier, and we're just going to cancel them out, which will give us 1. Or if you did L'Hopital's, where you took the derivative of the top and bottom, that will give you, I'll write the h on top to let you know I'm doing L'Hopital's. That will just get you 1 divided by 1, because the derivative of x is 1, and the derivative of 1 is a constant, so it goes away, which will give you 1 either way. So we get to the point along the x, or along y is equal to x, equaling to 1. But what if we wanted to do it a different way? So another way that we could get to 1, 1 is by the quadratic. So we could say y is equal to x squared, because we will have this line right here, which also gets us to 1, 1. So we're going to write over here, we're going to have our new line is going to go along y is equal to x squared. So for y is equal to x squared, we're going to do the exact same thing. We're going to replace our y with x squared. So we're going to have the limit as x approaches 1, because we're still going to the point 1, 1, of f of x and x, which is the limit as x approaches 1, of this time it's going to be x minus 1 divided by x squared minus 1. Now, there's a couple ways to do it. You could either divide everything by x squared, but I'm going to do it a little bit easier, or the way that I like to do it at least. We're going to use difference of squares to make this x minus 1 and x plus 1. Because now you can cancel these out, and we'll be left with 1 over x plus 1. And if we put our 1 in, because that's where we're approaching, that'll get us 1 over 2, which is going to be 1/2. So we can already see that going along these two different lines is going to give us two different answers. So we already know that the limit does not exist, because we're going from two different points. So limit of f at x and y of x and y approaching the point 1, 1 does not exist.